Welcome to class. In this video, we'll learn to spot the difference between linear and nonlinear ordinary differential equations. In this video, we're just going to discuss the linearity of ODEs. You can classify PDEs as linear or nonlinear, but it's a little bit trickier. So for now, let's focus on ODEs. This definition looks a little intimidating, but the idea is straightforward. We say that an ODE is linear if it has this form, but really the important pieces of this formula up here are the coefficient terms, the ANs. Right? Notice that I've written them all as a function of the independent variable only. So the coefficients of a linear equation do not include any other derivatives. Let's take a look at some examples of linear differential equations. The equation x double dot, if you recall, those are another notation for ordinary derivatives, minus 2x dot plus x equals 0 is linear. Do you notice I have an order 2 derivative, an order 1 derivative, and an order 0 derivative? So here, that would be my n is 2, right? I have the second derivative, and its coefficient has no derivatives. The first derivative term, its coefficient has no derivatives. And the final term, or the order 0 term, its coefficient has no derivatives. Neither does the right-hand side of the equation. So we would say this is linear. Let's take a look at another less obvious example. If I have something of the form y minus x dx plus 4x dy equal to 0. Now, immediately you might look at over here. I've got no derivatives over here, only x's, right? So that's good to go. The right-hand side is good to go. This piece looks a little iffy, though, because I have a y in the coefficient. However, remember, this is just if the coefficients of dy dx involve those independent or dependent variables. So if I rewrite this equation as y minus x plus 4x dy dx equals 0, it's a little more obvious now why these are linear. Because here I have an order 0 term, its coefficient has x's or constants only. I have an order 1 term, and its coefficients have x's or constants only. And the right-hand term and my order 0 term both involve x's only. Next, let's take a look at an example of some equations that are nonlinear. Let's start with a more obvious one here. If I have the equation 1 minus y prime plus 2y equals e to the x. We can see that the right-hand side looks okay. The order 0 term looks okay. But over here on my order 1 term, do you notice the coefficients involve the dependent variable, y, not x's? Because one term is enough to break this form, we can now say that this is a nonlinear equation. Let's look at a less obvious one, though. Let's look at the equation y prime squared equals tangent of y. Now, this is kind of a double whammy because neither term is linear. However, it's a little less obvious to see how this fits into the form. I would claim that on my order 1 term here, the coefficient is also the derivative. Notice I have dy dx times dy dx, which would be a function of involving a derivative. So this term is definitely nonlinear. Same thing over here. Over here, do you notice I have a function of y? So this looks like the right-hand side. And I would say here that g depends on y. So this is also nonlinear.